Okay, so I've had a special request to do the December 2022 1 hour Danish exam, Folkeskolens afgangsprøve, FP9. The 1 hour paper, the one without calculator, 50 short questions. So I'm just going to run through this kind of live. So we'll see how this goes. Okay, so exercise, so number in algebra, exercise 1. The sketch shows prices from a baker. So you've got the first picture, which is some kanelsnegl, some cinnamon snails. Normal price 1 for 19 kroner. Special offer price 3 for 49 kroner. And then you've got some sandwiches on the right. Normal price 1 for 39 kroner. Special offer price 2 for 59 kroner. So the first issue here is you've got to recognize the pictures, that the things on the left are the kanelsnegls and the things on the right are the sandwiches, which actually it doesn't give you, so you've got to know the Danish there, which is a bit odd for these exams. But anyway, how much does a kanelsnegl and a sandwich cost together? How much does a cinnamon twirly thing and a sandwich cost together? So that's the 19 plus the 39, which is 58. How much more do 3 kanelsnegler on offer cost than 3 kanelsnegler at the normal price? Okay, so 3 at special offer price is 49. 3 at the normal price is 3 times 19, which is 57. The question is how much more? So it costs 8 more at normal price. About how many percent do you save by buying 2 sandwiches on the offer in relation to 2 sandwiches at the normal price? Okay, so 2 sandwiches at the offer cost 78. 2 sandwiches at the normal price cost 59. So you are saving 19 kroner. So that's saving 19 kroner in relation to 17. So in relation to 78 that you'd normally have to pay. So it's 19 out of 78. You're saving 19/78 of the normal price. The saving has got to be in relation to what you'd normally pay. So 19, and then times 100 for a percentage. So 19 out of 78 times 100%. So it says approximately, so that's approximately 20/80ths times 100, which is approximately 25%. So I'm going with approximately 25%. At the same time, I'm sneakily going to do the exact number on my calculator, which of course I can't do in the exam. But exactly it comes to 24.3%. So actually nearer 24 than 25, but they ought to give that to you because I think the point of the question is sort of sensible rounding. So I would hope that there was a kind of range of acceptable answers that allows you to have that. Okay, when Sophia cooks marmalade, she uses 1,200 she uses 1,200 grams of berries and 6 deciliters of sugar. How many deciliters of sugar does she use for 3,600 grams of berries? Okay, so the given amounts are 1,200 of berries, but this is 3,600 of berries. That's exactly 3 times as much. So she's going to use exactly 3 times as much sugar. 3 times 6 is 18. How many grams of berries does she use for 6 deciliters of sugar? Okay, so the recipe has 6 deciliters of sugar. We're talking about if she uses 8 deciliters of sugar, so we're talking about 8/6 as much. So 8/6 of the normal 1,200 is the figure we are looking for. Now, I quickly spot here that 1,200 divides nicely by 6. 12 divided by 6 is 2, so 1,200 divided by 6 is 200. So that's just the same as 8 times 200, which is 1,600. Exercise 3. Sophia cycles 6 kilometers in 20 minutes. What is Sophia's average speed in kilometers per hour? Okay, so 6 kilometers in 20 minutes, 3 times as much in 3 times as many minutes, 18 kilometers in 60 minutes, so 18 kilometers per hour, in other words. Magnus cycles at an average speed of 21 kilometers per hour. How much can he cycle in 40 minutes? Okay, so if he can cycle 21 kilometers in 1 hour, well, you might spot that 40 minutes is 2/3 of an hour, so 2/3 as much is 14 in 40 minutes, so 14 kilometers. If I was going to do that a longer way, I'd say 21 kilometers in 1 hour, 21/60ths of a kilometer in 40 minutes, and then 21 times 40/60ths. Sorry, start that again. Let's get rid of that. Let's just get rid of everything here. Give myself the space. Yeah, if I was going to do that a longer way, I would say 21 kilometers in 1 hour, 21/60ths of a kilometer in 1 minute is what I meant to say, and then 21/60ths times 40 kilometers in 40 minutes. That's the kind of long fail-safe way of doing this, and that would give me 14. But if I can quickly spot something like the fact that 40 is exactly 2/3 of an hour, and I can quickly do 2/3 of 21 in my head, then all the better. Okay, at Sophia's after-schooler boarding school, 35% of the pupils are 15 years, 40% of the pupils are 16 years, and the rest are 17 years. How many percent are 17 years? Okay, so 30 plus 40 is 75, so 25 must represent the rest. There are 150 pupils at Sophia's after-schooler. How many, or boarding school, how many are 16 years old? Okay, so that's 40%. So 40% or 40/100ths of 150. Again, I can quickly do this in my head because 40 times 150 is, well, 4 times 15 is 60. So 40 times 150 is 6,000. So 6,000 divided by 100 is 60 pupils. Okay, calculations. I will not say much about these as I do them. There's nothing really much to explain conceptually. You ought to be able to do the basic arithmetic. So I'll just run through these, doing these my way. 8, 9, 1. 1942 for the first one. Next one's a subtraction. 1403 698. So that's 5 and the 1 0 and the 1 7 705. Yep. 7 times 508. Easier to set it out as 508 times 7. 56, 35, 3556. 4236 divided by 6. 4236 divided by 6. I'll set this out the short way rather than the long way that tends to be predominant in Denmark. 706. Okay. Insert numbers so that the expressions are true. So this is more arithmetic. 287 equals something plus 2.7. So that's the same as saying what is 2.87 minus 2.7, which is 0.17, comma for a decimal in Denmark. 8 times something equals something times 12. Okay, so 48 equals something times 12. So the thing is 48 divided by 12, which is 4. A quarter plus something equals 7/8. Okay, well that's the same as saying 2/8 plus something equals 7/8. So that's got to be 5/8. So I guess you need to know how to do fractions. I've got lots of videos on fractions if you want to look at that. Equations. 4x equals 60. So divide both sides by 4 to get x equals 15. I've got lots of algebra videos if you want to look at those. Okay, we've got a thing with x on both sides. 5x plus 3 equals 10x minus 7. I'll get rid of the minus first. So I'm going to add 7 to both sides to get 5x plus 10 equals 10x. I've got x on both sides, so I'll take as much x as I can from both sides. So taking away 5x from both sides, 10 is equal to 5x, and then divide both sides by 5 to get 2 is equal to x, so x equals 2. Next one, let's just clear all this and make space. Okay, so I've got x over 3 plus 2 equals x minus 4. Well, that's a bit of a mess. Let's get rid of the fraction first. So I'm going to multiply everything by 3 to get a whole x. But I need to remember to multiply everything throughout by 3. So 2 times 3 is 6. X times 3 is 3x. And minus 4 times 3 is minus 12. Okay, that looks a bit more friendly. I think I'll get rid of the minus now. So I'm going to add 12 to both sides to get rid of the minus 12. So I'll just have 3x on the right. But I've got to remember to add 12 the other side as well. So x plus 18 is 3x. Now let's take away some x's from both sides. So if I take away an x from the left, I'll just have the 18 on its own. And I've got to take away x on the right as well. So 18 is 2x. And divided by 2, 9 is equal to x. So that's my final answer. X equals 9. And I can just check that. So x over 3 would be 9 over 3, which is 3. 3 plus 2, which is 5, equals 9 minus 4, which is 5. So that works. Okay, exercise 8. Brugersleerreining. Suggestion calculation. I wonder what that means in English. Oh, I see. Multiple choice. So multiple choice calculations. What is the result of 43.6 times 0.8. Well, I like to do these with whole numbers first. So 436 times 8 is, let me just do this. 8 carry the 4, 24 plus the 4, 8 carry the 2, 32 plus the 2, 34, 3, 4, 8, 8. So it's not 436, it's 43.6, and it's not 8, but it's 0.8. So that's moving the decimal one place there and one place there. So it's moving the decimal 2 places in the answer. So it's 34.88. Also, just common sense ought to tell you the value of this, because about 43 times a bit less than 1 should give you something of the order of a bit less than 43. So you should have a sense of, whether it's around 43 as 34 is, rather than being around 3 or around 300. What is the result of 45 divided by 0.6? Okay, so 45 divided by 0.6 is going to be the same as 10 times as much divided by 10 times as much. So it's the same as 450 divided by 6, which should actually go nicely. 450 divided by 6 is 0, carry the 4. 7 6s are 42 plus lift the 3 over, and 75.0. There we go. Moving on. Which expression has the same value as 4n put across n? Well, it's not the first one, because that's n squared. The next one is 4n. 4 plus n doesn't simplify, as do neither of the others. So it's n plus n plus n plus n is 4n. Which expression has the same expression as p cubed? Well, it's not p plus 3. P times p times p is p cubed. That's right. 3 times p is just 3p. P divided by 3 is p over 3, and 3 over p is something else. Okay. The sketch shows an octagon and its side lengths. The perimeter, Umkreis, of the octagon is what? So you've got some A's and B's. Let's add them up. You've got 1, 2, 3 B's, and then another 3 B's there makes 6 B's. And then you've got 1, 2, 3, 4, 5, 6 A's. So it's 6A plus 6B. Then they want the area of the octagon. So I'm just going to get rid of some of my scribblings there and do the area. So the way to do this, of course, is to just split it up into rectangles. So I'll do it with a couple of vertical lines. I could have done it horizontally. So I've got 2A times B is 2AB. I've got, well, if that's 2A there and that's A there, that's got to be A down the side. So I've got 3B times A is 3AB. And then I've got 2A times B is 2AB. So altogether I've got, let's just change colour. I've got 2ABs and 3ABs plus another 2ABs makes 7ABs altogether. If I'd split it up the other way, should have come up with the same answer. Okay, so rewrite these lengths. So 907 centimeters is 9.07 meters, 100 centimeters in a meter. 100 meters is 0.1 kilometers, 1,000 meters in a kilometer. 3.06 kilograms is 3,060 grams. 1,000 grams in a kilogram. And then deciliters, anything with deci is always 10. There's 10 deciliters in a litre, so 1.2 litres is 12 deciliters. What's this? This is exercise 12, similar triangles it's looking like, or possibly trigonometry. Let's have a look. Below is a sketch that's... below is a sketch... Hirone and Skizze. Oh, here is a sketch of Sophia in front of an apple tree and an elm tree. Sophia is 1.5 meters high. Yeah, so this looks like it's all about similar triangles. It's the fact that this triangle here with Sophia in is similar to that triangle there with the apple tree and that triangle there with the elm tree. So they're similar in the sense that they've all got the same angle there. They've all got a 90-degree angle with the trees and the person related to the vertical, and therefore they've all got the same angle at the top. So they've got all three angles the same, so we're talking about similar triangles, or in Danish, lige dannede trekanter. Okay, so how high is the apple tree? Well, it's the fact that in similar triangles, the ratio between corresponding sides, tilsvarende sider, is the same. So the 1.5 divided by the 5, 1.5 over 5, is the same as, let's call it A, the height of the apple tree, divided by the length there, which is 10. I'll multiply both sides of that by 5 to get 1.5 is equal to, let's just do that somewhere where there's a bit more space. Okay, I've said that divided by that in the small triangle is the same as that divided by that in the big triangle. So 1.5 over 5 equals A over 10. Multiply both sides of that by by 5 to get 1.5 is equal to 1.5 is equal to, my iPad's going crazy at the moment. 1.5 is equal to 5A over 10. And then multiply both sides by 10 to get 15 is equal to 5A, and divide both sides by 5 to get A equals 3. So the height of the apple tree is 3. I'm just going to get rid of all of this. It's getting in the way a bit. Yeah. So the height of the apple tree is 3, so that 3 divided by 10 is the same as 1.5 divided by 5. Or common sense, without doing all that calculation, you can see that if the 10 is twice as much as the 5, then the apple tree has to be twice as much as her height. So there is a sort of common sense way of seeing that quickly. 3 meters anyway. The elm tree is 9 meters high. What is the distance between the apple tree and the elm tree? Okay, well, we're going to have to work out the whole distance in the triangle first. So I'm going to do it using the apple tree. So I can see that the elm tree is 3 times as high as the apple tree. So it's got to be 3 times as far away from the point as the apple tree. Okay, so 9 over 3 times the 10 gives you 30. So 30 is the distance of the apple tree, sorry, the elm tree from the point in the triangle. But the question is asking for the distance between the apple tree and the elm tree. So 30 minus the 10 there gives you 20 meters. The sketch shows a trapezium. I'm just keeping an eye on the clock now. So I'm 25 minutes in. I'm not sure how many questions I've done. How big is angle U? Well, let's just try and fill in all of the angles on this. So that's 90 for a right angle. That's 90 for a right angle. We've got a triangle there, so 50, 90 and 40 at the top. We've got something on a straight line, so 90 there, 90 there, and then we've got a 4-sided shape there, a quadrilateral. So that's got to add up to 360. So 360 minus 90 minus 90 minus 105 makes you 75. And then how big is angle B? V. So V is on a straight line with the 40. So 180 minus 40 gives me 140. Okay, so you've got these, which are 15 centimeters. I think I'm going to put everything in centimeters. So 6 meters is 600 centimeters, and 600 divided by 15 is 40. So there's 40 of those that way. And 4.5 meters is 450 centimeters, and 450 centimeters divided by 15 is 30, isn't it? So 40 plus 30 is 70. Well, in fact, I don't need to have got the first bit of the question in order to be able to do the second bit of the question. So it's just asking for the whole area in meters squared. So this bit here on the left, 2 meters times 4.5 meters is 9 meters squared. And this bit here, 6 meters times 2 meters is 12 meters squared. So altogether 21 meters squared. Okay, it says exercise 15. Below is a sketch of 2 prisms and a formula for the volume of the prism. So the volume of a prism is just the end area times its height or length. So V is the volume of a prism. G is the area of the prism's ground area. So a prism always has kind of the same shape throughout. So it's the area of that same shape multiplied by the length through which that shape is extended. How big is the area of the blue prism? Okay, so it tells you that the ground area is 60 and the height is 8, so it's just 60 times 8, which is 480. How big is the area of the red prism's ground ground surface, ground area. So it says the volume is 180, the height is 6, so 6 times something gives you 180, so you've got to do 180 divided by 6, which is 30. Okay, Magnus and Sophia each describe a graph in the coordinate system. My graph is a straight line. It cuts the y-axis at 3. So a straight line that cuts the y-axis at 3. My graph is not a straight line, and it also cuts the y-axis at 3. Okay. So, which equation best fits Magnus's description? So if Magnus's is a straight line, it's going to be y equals, so a straight line generally is in the form y equals something x plus something. The something x is the gradient and the plus something is where it cuts. The intercept, or skæringspunkt in Danish. And we know his cuts at 3, so it's going to be something like y equals, a number, something x plus 3. So looking at these, so it's not going to be y equals x squared plus 3, because that's not going to be a straight line. So it's got to be y equals something x plus 3, and the only one that fits that is the fourth one. So y equals x plus 3. And then Sophia says, my graph is not a straight line. So it's not going to be y equals 2x minus 3, because that's going to be a straight line that cuts at minus 3 and goes down. It's got to be y equals something with x squared out of these options. Well, it could be something with x over 3, because that would be a not straight line that kind of does that. But it's still got to have the plus 3 to cut the y-axis at 3. So it's got to be one of the ones that's got a plus 3. It can't be minus 3x plus 3, because that would be something that cut at 3 and then had a gradient of minus 3 and was a straight line. So that's a straight line, so it's not that one. Out of the options, it can only be the quadratic one, the one with the x squared, because that's not a straight line, and then minus 3. Sorry, plus 3, I meant to say. Yuck. Okay. Tangling myself up a bit there. The drawing shows a red quadrilateral and 5 blue quadrilaterals, A, B, C, D, and E. Put an X in each one of the following. Which of the blue quadrilaterals can you transform into the red triangle with a parallel forskydning, like a translation in English, that's called. So which one of the blue ones can you translate into the red one? So that means which one can be changed into the red one just by moving left and right or up and down without rotating or reflecting. So you can see that D can be just shifted a certain number of units up and left. So the answer is D for that one. All the rest need to be rotated or reflected. Which of the blue quadrilaterals can you transform to the red quadrilateral with a reflection in a line? Okay, let's have a look at that. Well, this is tricky. So you might think that you could reflect A, but then if you reflected A, there's no way you can reflect A so that it ends up in the same place as the red one. You can reflect it so it looks like the red one, but there's no way you can reflect it so it ends up in the same place as the red one. And the same with E. You might think you can reflect E so it looks like the red one, but there's no way you can reflect it so that it ends up in the same place as the red one. So actually, the answer is B, with a mirror line down there, and in that mirror line you can reflect B so that it ends up in the same place as the red one. So that's actually B. Tricky question. Which of the blue rectangles can you rotate over to the, can you transform to the red triangle with a rotation about a point? Okay, so one of these blue ones can be rotated about a single point to give you the red one. Let's just get rid of those. So if it's a rotation, then it's got to be something in the same orientation as the red one. So it can't be B, because wherever you rotate that, it's kind of a reflection of the red one. And the same applies to A, and indeed to E. So it's got to be either C or D, because that's actually the only one that looks the same as the red one. So just thinking about this, we've already had D as an answer, so I'm inclined not to put D. So I'm thinking it should be C. So you should be able to rotate C into the red one. I'm just trying to figure out where that center of rotation is. So that point's got to go to that point, and then the perpendicular bisector of that is around there. That point's got to go to that point, and the perpendicular bisector's around there. Yeah. So I think you can rotate them both around that point, and I can see it now. So C rotated 90 degrees around that point gets you to the red one. That let's go for another color there. That rotated 90 degrees takes you to there. Yeah. So C with a 90-degree anti-clockwise rotation around that point there gives you the red one. So the answer is C anyway. Statistics and probability. The diagram shows information about 18 to 25-year-olds continuation of youth education in Denmark in 2020. Blue ones completed youth education. Green ones are in the process of youth education, and the orangey ones have no youth education. About how many 19-year-olds, so that's 19-year-olds here, have completed a youth education? Okay, so it's the blue ones. So it's a little bit more than 20,000 gosh, I'm going to say around 21,000, and hope there's a little bit of margin for error allowed there. About how many of the 22-year-olds are in the process of youth education? Okay, so that's these green ones here. So I'm going to say that's, it's hard to tell, about 59,000 minus, that looks like about, it's really hard to tell on here, but perhaps on the actual exam paper, that's a nice centimetre or something between the things, and you can tell from that. But it's about 59,000 divided by, I'm saying about 52,000. I'm gonna make a qualified 7,000 there, but I suspect on the actual exam paper that might be something you can measure a bit more accurately there. Not sure how much margin for error there is on there, but in any case it's something of that order, and that's how you're supposed to do it. About how many percent of the 25-year-olds have completed a youth education? Okay, so it's what percentage is this out of the whole thing? So again, hard to read it off, but I'm reckoning that that's about 160,000 out of about 80,000 times 100 for a percentage. I'm putting that at about 20%. Probably a bit of margin for error there. All of these say circa, so hopefully there's a bit of margin for error. Okay, we've got a box plot. The pupils in 9A have collected some data about how much money they've used on an online game in a month. The box plot shows the distribution of their data. What is the biggest amount that a pupil in 9A has used in the online game? There's the biggest amount, 500 kroner. The box plot shows that 75% of the pupils have used at least how much? So a box plot shows you the lowest value to the highest value. So 0 to 100% of the people are in there. 25% of the people and 75% of the people are shown by the edges of the box. And 50% of the people, the median in other words, is the line in the box. The box plot shows that 75% of pupils have used at least how much? So you've got to be careful about whether this question is asking you for the top 75% or the bottom 75%. And reading that, it's asking you for the top 75%. So 75% of the pupils have used at least 20 kroner, whereas the other 25% have used less than 20 kroner. So 20 kroner is the cut-off point for the bottom 25 and the top 75%. Exercise 20, and happily it's the last three questions. The drawing shows 5 jars with red, white and blue balls. Magnus has to pick a random ball from the jars. Which glass must Magnus pick from to have an equal probability of picking a white or a blue? Okay, so not A, because that has different numbers of whites and blues. Not B, not C. D has 1 white and 1 blue out of 4 balls, so it's D. Which jar must Magnus pick from if he wants to have the biggest probability of picking a blue ball? Okay, so the probability of a blue ball is 1 out of 5 in the first one. It's 3 out of 5 in the second one. It's 1 out of lots, 10 in the third one. It's 1 out of 4 in the next one, and 2 out of 3 in the last one. So 2 out of 3 is the only one that's bigger than a half. So E gives him the best chance of a blue ball. Which jar must Magnus pick from so that the probability is 0.6 of getting either a blue or a red? Well, let's just do all of those. So the chance of either a blue or a red in the first one is, so there's 3 of those out of 5. 3 out of 5 is 0.6. Oh, so I can already see it's the first one, A. But let's just complete it. Second one, 4 out of 5 is 0.8. Third one, 5 out of 10 is 0.5. Fourth one, 3 out of 4 blue or red is 0.75. And then the last one, 2 out of 3 blue or red is 0.6 recurring. Okay, so that's done. Errors and omissions excluded. Comment in the comments if you observe something drastically wrong.